Hello everyone. So in this particular video, we will be seeing how we can do image classification using machine learning. Okay, so not deep learning, machine learning. So obviously for machine learning, you will be using something like sklearn. Okay, so you will be using these libraries, this library for the algorithms. So how to do image classification? So in this, basically you'll have to do a couple of steps. Okay, so one, two, three, a couple of steps. The first step is going to be your data collection or whatever from Kaggle or something. Doesn't matter wherever you get it. Okay, so first you'll have to get the data. After that, assuming it's already pre-processed and you are not into EDA, that all those things are let's just remove that out of the way, because there is an assumption that it is, the data is in format we want, and EDA is not required. Okay, fine. The second thing that you need to do is feature extraction, right? Feature extraction. Then you will train the model. Okay, and finally you will validate the model. So these are the 4 steps that we are going to do. Okay, and our most focus will be over here. So let's start with step number 1, okay, which is your data collection. So how will you collect data? Okay, so step number 1, data collection. So for that, very easy. Either you use Kaggle. Okay, so you can use Kaggle, or you can use UCI repositories, whatever you use, or you have your own custom data set that you got it from the internet from somewhere, or datasets dot, I think Google Datasets is also there. Google Datasets, it's a website where you can find many datasets basically. So let's say you have got it sorted out and you have your folders. Okay, so let's say we are doing cat versus dog, so you have one folder of cats. Let's say there are 10,000 images over here, and then there is dogs, the folder of dogs, and then there are 10,000 images over here as well. Okay, so let's assume this is the case. Now we'll go to second, that is feature extraction. So let's say you are trying to do feature extraction over here. Okay, so extraction. Okay, now this is the main problem with regard to machine learning, that too in image classification case. In image you have basic images. It is a tedious process to take features out of it. Now there are ways, I'm not saying there are no ways, there are ways, but generally you don't want to take out features. You just want to give the raw image to a model. That is where deep learning comes in, and then finally get the result. Okay, you don't want to do features and then train the model. Okay, you want to skip this step, and deep learning is basically going to help you skip this step. However, since we are doing machine learning, we will find the way to figure out how to do feature extraction. So in machine learning, when it comes to images, there are a couple of ways that you can use. Number 1 is called your HOG, histogram of oriented gradients. Okay, histogram of oriented gradients, whatever. Okay, so this is basically now I'm not going to get into that. I'll make a separate video and even a project on this. I am thinking about that should be coming soon. So HOG features you can get from sklearn. Okay, sklearn library, sklearn images, or sk images, I think it is called sklearn. Yeah, sk image something it's called. Okay, just look into it, you can get the HOG features. Okay, basically these are vectors. Okay, vectors, and then you can use this vector for training your algorithm, which will see in step number 3. Or you can do sift features. Now the problem with sift features is you will not have constant length vectors. This will be a problem, constant length vectors. In some of the implementation, I have seen that they give constant vectors, constant length vectors, but in some I have seen they don't give constant length vectors. So we will see how to deal with that particular situation. Okay, after that there is something called as ORB, again similar. So sift is kind of proprietary. Okay, it's a proprietary algorithm. ORB is free to use. That's the difference. Again, getting into the theory is not possible, especially this will take a lot of time to explain because it's a little bit complicated. Okay, mathematically complicated. So this will take significant amount of time, and that's why I'm not going into this. This will also take time. Okay, and the last one that you can use so one more is there. It's called color histograms. Okay, color histograms. Again, what they are, what they, how we are going to do it is a completely different thing. We will be making a playlist on projects basically, or even these concepts, these all these concepts I'll be making. This one is going to take a lot of time, this one is taking time, so we'll make the videos on all of these theory videos and then implementation. So don't worry, everything is coming. But yeah, you can also basically RGB values are there, let's say only in RGB domain, and then we will find features out of it, right? So this is what we are going to do. Now coming to step number 3. So once you have this, any of these, you will basically have vectors which will have, and each of this column will be your feature 1, feature 2, up to feature n. Okay, let's say these are the, which means this is now, and let's say you have more examples, so you have an entire data frame. Okay, so for every image, let's say cat image, you're going to have this vector. For dog image, you're going to have this vector, and even in the target you will have over here cat, and here you will have dog, like that. Okay, so like this you are going to have your data set. After that you can find, so since this is there, this you have already gotten the data frame. After that it's just normal, you take a sklearn, and then you can use simple algorithms, like for example you can use logistic regression, you can use SVM, support vector machine, you can use neural network as well, the MLP basically, multi-layer perceptron. Okay, so you can use this, you can use decision trees, you can use let's say your ensemble methods. Okay, so bagging, boosting, and all those things. Basically you can use so many things over here, right? So many algorithms you have for classification. And since dog versus cat we are doing, which is basically image classification, so you can use classification algorithms that I have already mentioned on the top over here, over here. All these algorithms you can use. Okay, so let's say you have got sorted out, you got this sorted out. So assuming you have done proper train test split, you can definitely do validation of your model. Okay, so let's say you have trained a logistic regression model on the data set that you had created in the second step of feature extraction. Then you can test it using the or you can validate the model. Okay, validate the model using that. Let's say you did a 80-20 split. Okay, let's say you did a 80-20 split. You can definitely figure out your testing accuracy or validation accuracy, whatever you call it. Okay, validation accuracy in our case basically, because we will not be testing, we don't have data right now, we took a 80-20 split. If you want to do testing also, you would ideally want 70-20-10. So this will be training, this will be validation, and last this will be inference or testing, whatever you want to say. Okay, so this is the idea. And yeah, theoretically this much. Don't worry, we will have many, I would say, projects that will be coming along in this way. And most of these concepts, theory will be a little time consuming. That's why you will see, a lot of people just don't go to the theory of this part, you just go to practicals and projects and get the results, and these things actually work. But let's say if you want to do something that is a little bit more advanced, you should definitely know theory. Okay, so I hope you understood that. I hope you liked the video. Please like and subscribe. Thank you very much, and bye.